Good morning students. This session is for class 11th and we are studying continuously the motion in plane. In last sessions we have completed circular motion in detail and today we are going to study another motion which is an example of motion in plane, and that is very important topic of your syllabus, and that is known as projectile motion. Okay students, there is one most important point that you must remember, that in this session we are again going to use vector and vector resolution. So if you have any doubt about these topics, must see the videos based on the vectors. In last classes we have already discussed about vectors in detail. Okay, so try to do these things to understand the concept of different types of motion in plane. Okay, so let us start this session with the topic that is known as projectile motion. Okay, so let us see the objectives of this session, or you can say this topic. So the learning objectives are as follows. The first one is the define projectile motion. So from this session you will get the knowledge of definition of projectile motion. Then we will able to explain the projectile motion. After that we can identify the types of projectile motion. Then fourth one is differentiate the types of projectile motion. Fifth one is explain and summarize all the kinematics equation in solving projectile motion problems. And the next one is solve problems involving the types of projectile motion. So these are the learning objectives of this session. Okay, so let us start. So you can see this is the first question related to the topic, that is what is projectile. So here we are going to understand about the projectile. What is actually projectile? Okay, so you can see here the definition is given, and you can see a picture in which a boy is throwing a ball and the ball is moving under the effect of gravity in earth atmosphere. Okay, so let's see. Projectile, any object which projected by some means and continues to move due to its own inertia. You know inertia is related to mass, so it is mentioned here. So what is projectile? You can see, I hope you understand, any object which projected by some means and continues to move due to its own inertia. So if you throw any object except perpendicular to the earth's surface, or so you can see it will move in such a way, you can see in this figure. So the object in this case is considered as a projectile. Okay, now you can see the most important point about projectile is projectiles move in 2 dimensions. So that these are the examples of motion in plane. Since you know that a plane must have at least 2 axes, okay, or you can say 2 dimensions, so that the circular motion, the projectile motion, these are examples of motion in plane, because the characteristics of these motion for complete explanation need at least 2 coordinate axes. So they are examples of 2-dimensional motion, or you can say motion in plane. Okay, so let's see. A projectile moves in 2 dimensions, therefore it has 2 components, just like a resultant vector. So in this case you can see that this particle is supposed initially at this point and it is moving like this. So you can see, if suppose point particle is at this point, that is point P, So you must need some axis, some coordinate of x-axis and coordinate of y-axis to give its position. Okay, similarly at each point of its motion we need at least two coordinate x and y. If this particle is moving in yz plane, then you must need two coordinate axes y and z, and similarly for zx. Okay, so I hope you understand why it is considered as two-dimensional motion, because at any point to characterize or to explain its motion we need at least two coordinate axes, or you can say two dimensions. So this is an example of motion in plane or two-dimensional motion. So let's see the velocity. So it is actually moving in this direction at this point. So if velocity is u at this point, so this velocity can be resolved into two rectangular components here. First one is perpendicular to the earth surface and second one is parallel to the earth surface. The perpendicular component is known as the perpendicular component, and the component which is horizontal to the surface is considered as horizontal component of velocity. So you can see here horizontal velocity component. So we are going to understand about this component that is represented by blue color in this picture, and it is parallel to the earth's surface. Okay, so you can see here it never changes and covers equal displacement in equal time periods. This means the initial horizontal velocity equals the final horizontal velocity. So this is the very important points about the horizontal component of velocity in projectile motion. And this paragraph says that the horizontal component of velocity remains unchanged throughout the motion. It means its initial velocity, it means we are considering about the initial horizontal component and then final horizontal component, and you can take any arbitrary point between the initial and final. At all these points the magnitude and the direction of this component remains unchanged. You can see the blue color arrows does not change their size. Okay, since you know that a vector is represented by arrow and its magnitude is given by the length of the arrow. So you can see here the vertical component that is presented by the red color is continuously decreasing in size. This shows that the perpendicular component is decreases with increasing the height, and after that it is increasing when it start moving in opposite direction. Okay, but the horizontal component is represented by blue color is of the same length. It means it does not change at any point throughout the motion. It means you can say that the initial component of the initial value of horizontal component of velocity is equal to the final value of horizontal component of velocity. Okay, so it is mentioned here it never changes, covers equal displacement in equal interval of time. Since the value of this magnitude of this horizontal component is not changes, it means it must cover equal distance in equal interval of time. So this means the initial horizontal velocity and equal to the final horizontal velocity. Okay, in other words the horizontal velocity is constant. So the finally after this is the conclusion of this explanation, and this is the horizontal velocity is constant. Now there is question why it is constant. So we must think about this part, why it is constant. So we will discuss later about this. Because gravity does not work horizontally to increase or decrease the velocity. So the reason of this why is gravity does not work horizontally to increase or decrease the velocity. Since let me give let me explain this thing by giving example. So this one is the horizontal velocity. Let me draw another vector. Suppose this one is the horizontal vector. Okay, now the gravity is working along this direction. You can see the direction of this gravity and this velocity is 90 degree. So this force, that is the gravitational attraction force, cannot change the magnitude of velocity because the perpendicular force cannot change the magnitude of the velocity, but it can change the direction. Okay, so it can only change the direction, but it cannot change the magnitude of the horizontal component of the velocity, so that the horizontal components remains unchanged throughout the motion, because the direction of the gravitational attraction is always perpendicular to the direction of the horizontal component of velocity. So this is the reason of this y, that is why the horizontal velocity is constant, because the gravitational attraction is always perpendicular to the horizontal component of velocity, so it does not change. Now let us discuss about the vertical velocity component. So you can see in this picture the vertical velocity components are represented by red vectors, and you can see the length of these red vectors are continuously decreasing in first half of the motion, and then in the same way it is increasing. So it means these velocity are variable in this motion. It means vertical velocity component is not constant, but it is variable throughout the motion. So you can see here these component changes due to the gravity, because these velocity component is either in the direction of the gravity. Here you can see these two are in the direction of the gravitational attraction, and here they are opposite to the direction of the gravitational attraction. So you can see changes due to the gravity does not cover equal displacement in equal time periods. So since they are variable, they cannot cover equal displacements in equal time periods. Okay, so here you can see that both the magnitude and the direction changes. So in this case, about the vertical component, you can see in the first half their direction are upward and their magnitude are continuously decreasing, and in second half their directions are in the same as the direction of gravitational attraction, and their magnitude are continuously increasing. So both the magnitude and direction changes. As the projectile moves up, the magnitude decreases and its direction is upward. So this we have already discussed. As the projectile moves up, the magnitude decreases and its direction is upward. So you can see here the magnitude is decreases when it is moving upward, and its direction is opposite to the direction of the gravitational attraction. Okay, so you can see here as the projectile move up, the magnitude decreases and its direction is upward. As it moves down, the magnitude increases and direction is downward. So you can see here as it moves down, the magnitude increases and the direction is downward. Okay, so I hope you understand the concept of this part, actually about the vertical component of velocity. You can see in this picture also the velocity component, that is vertical velocity component, is continuously decreasing when the projectile moving upward, and it is increasing in the same ratio when it is moving downward. At the highest point this component is 0. This is very important point for the projectile motion. So must remember that at highest point, at peak point of the motion of the projectile, the value of the vertical component is 0. So at this point here, you can see at this point this is the maximum height point. At this point the vertical component of velocity is 0. Okay, so must remember this part is very important, and I hope you have concept of vector resolution, because it will be very beneficial for you to resolve a vector in the next step of this session. Okay, so let us combine the things which have already discussed in this session. So combining the components, you can see here components horizontal and vector. It means in projectile motion the velocity of the projectile have two components. First one is the horizontal component and second one is the vertical component. Then if you are talking about the magnitude of these two, so the magnitude of the horizontal component is constant throughout the motion, whereas the magnitude of the vertical component is changes. Now about the direction, so the horizontal component always must have same direction and it is parallel to the earth's surface. And about direction of vertical component, so it is changes, and during when projectile moving upward, its direction is opposite to the gravitational attraction, and when projectile moving downward, its direction is same as the direction of the gravitational attraction. So you can see here these components produces what is called a trajectory or path. This path is parabolic in nature. So after or combination of these two component of velocity vectors together produces a trajectory of the projectile, and that trajectory is found as a parabola. Okay, or you can say parabolic in nature. So this is about the projectile motion. Now there is another type of projectile. This one is known as horizontally launched projectile. So this one is a special case. Let's see about this one. The projectile which have no upward trajectory and no initial vertical velocity. So suppose you are at roof on some building, okay, and you throws a projectile in horizontal direction, that is horizontal to the earth's surface. So these projectiles satisfy the condition, that is which have no upward trajectory. It means it does not move upward from this roof, and there is no initial vertical component, because initially its velocity is only horizontal to the earth's surface. So its vertical component, that is toward the earth's surface, is 0. So its vertical component is 0 and its horizontal component is something that is exactly the same as the initial velocity of this projectile. Okay, so I hope you understand. Let me repeat these things. Suppose you are on roof of a building and you throws a projectile parallel to the earth's surface. Okay, so in this case the initial velocity of this projectile is completely parallel to the earth's surface, and its value is exactly the same as the initial value of the velocity. It means initially at t is equal to 0 there is no component of the velocity toward the earth surface. Okay, it means you can say Vox means its velocity along x-axis is equal to the Vx, that is initial velocity, and it is constant throughout the motion. So this is a different case of this projectile motion, in which we throw projectile, or you can say any object, from some height and horizontal to the earth's surface, and you will get these type of path. And after study, this path is also found the part of a parabola. Okay, so the motion is considered as projectile motion. Okay, so I hope you understand. This one is the different type of one of the different case of the projectile. Now we are going to study some characteristics of horizontally launched projectile. So let's see. To analyze a projectile in two dimensions, we need two equations, one for x direction and one for y directions. Okay, and for this we use kinematics. So to explain the projectile motion, we must need two directions, or you can say two coordinate axes. First one is x axis and second one is y axis, you can say. So here you can see that this x is equal to v naught x t and y is equal to, why it is taken, because this x is equal to v ox t. So this one is along x axis and the time interval. Because along x axis there is no acceleration, so we must use the simple formula, velocity is equal to distance upon time, or you can say displacement upon time interval. Okay, so this is the same formula, x is equal to v into t. Okay, because in this direction there is no acceleration, so we can use the simple formula for uniform motion. But along y axis the motion is accelerated motion, and you must use y is equal to 1 by 2 gt square. So this y is equal to half gt square, because acceleration in this case is acceleration due to gravity, so it is taken as g. Since initial velocity along y-axis, it means you can say the vertical component of velocity is 0 in this case. So y is equal to 1 by 2 gt square here. Okay, so I hope you understand why it is 1 by 2 gt square, because here it is used s is equal to ut plus half at square. This is the equation number 2, that is s is equal to u, but u is vertical component into time plus half gt half g t square. Okay, so this is the formula. But since initial vertical component of velocity is 0, so our formula is s is equal to half gt square. Since vertical component of velocity is taken as y, so it is y is equal to 1 by 2 gt square. So this is the final result. Okay, so I hope you understand. So remember, the velocity is constant horizontally, so that means the acceleration is 0. You can see here, remember the velocity is constant horizontally, so that means acceleration is 0. So since acceleration is 0, we are using this formula. Similarly in this case, remember that since the projectile is launched horizontally, the initial vertical velocity is equal to 0. So since initial vertical velocity is 0, but the motion is accelerated under the effect of gravitational force, so the equation becomes y is equal to 1 by 2 gt square. So in time t, this shows that in time interval t, the projectile travels distance x along x axis, and a distance, you can say displacement also, the displacement y along y direction, or you can say y axis. So at the same time it will be at x distance from the origin along x direction, and the distance y from origin along y direction. So these two are the coordinates actually of the particle after time t from the origin. So you can see here horizontally launched projectiles. Let's see this example. So a plane traveling with a horizontal velocity of 100 meter per second is 500 meter above the ground. At some point the pilot decide to drop some supplies to designated target below. Then first part, how long is the drop in the air? B, how far away from the point where it was launched will it land? Okay, so you can see this one is the example of the horizontal projectile. Okay, so the plane is at a height of 500 meter and its velocity is 100 meter. When pilot release something from this plane, so initial velocity of the object is 100 meter per second and in the same direction as the plane. So the initial velocity in this case is found to be along x-axis is 100 meter per second. Okay, now the vertical displacement to reach the ground is y is equal to 500 meter. The vertical component of velocity is 0 when the object was released from the plane. Its complete velocity is in the same direction of the plane, and the g is minus 9.8 meter per second. This is the value of acceleration due to gravity, but we can take positive also. It depends on the direction, negative and positive. Okay, now in this question we have to find out the value of t, the time after that it will, how long it drop in air, and second one is how far away from the point where it was launched, so the value of x. Okay, so for this purpose let us solve by using the equations we have already discussed in previous slides. So for y you can write half gt square since its initial velocity is 0. So in this case you can write y is equal to half gt square. So the value of y is 500. If you take y as positive you can take this 9.8 as positive, and if you take this one is negative this should be also negative. So it depends on the practice. Okay, so this one is 500 is equal to 1 by 2 into 9.8 into t square, and after solving this equation you will get this 1000 upon 9.8 and this will be equal to 102.04. T square is equal to, so after solving t will be 10.1 seconds. So this will be the value of t. Then it means we get the value of the first part of this question, and that is t is equal to 10.1 seconds. Students, in many questions the value of g is given as 10 meter per second square. So in that cases you can take this one as 10 and your calculation will be quite easy in that cases. But if this is not given you must take it as 9.8 meter per second square. Okay, so as in this case it is not given that the value of g is 10 meter per second square, so it is taken as 9.8 meter per second square, or you can say meter per second per second. So t is equal to 10.1 seconds. Now in second part, how far, it means we want to find out the value of x. So for this case we have the magnitude of the horizontal velocity, that is 100 meter per second, and the time interval, that is 10.1. so you can find out the value of x by using the formula x is equal to vxt into t, where this one is the horizontal component, because this horizontal component remains unchanged throughout the motion. So we can use a simple formula, that is distance is equal to velocity into time. Since velocity is constant, it means it is in uniform motion, it must travel equal distances in equal interval of time. So you can use the simple formula distance is equal to velocity into time, and by using this formula you can find out the value is given here, that is the value of v naught is 100 and the value of time, that is 10.1. this is calculated in the part A, that is 10.1. so x is equal to 100 into 10.1 and it will be, you can see, 1010 meter. Okay, so this is the result of x. So you can, I hope you understand how we solve this question. Similarly, you can solve questions based on the topic horizontally launched projectile. Students, try to solve at least 10 questions based on this topic, and this practice will help you to solve many questions based on application labels and higher order thinking skills, and you can apply these things for different experiment also. But the most important point is practice. So keep practicing and you will be able to understand the concept in more deep way. Thank you for watching.